All right, let's jump straight into this. In the interest of time, for this topic to review today, I'm only going to cover the questions that we did not get to cover in class during our initial review. That is going to be questions 3, 4, 5, 7, 10, 11, 13, and 14. All right. So let's get right into it. Number 3 asks us about the shape of an underground pool, which has a parabola modeled by this function, f of x equals x squared plus 8. I'm going to highlight that. It asks us what point represents the bottom of the pool. So when we have these quadratic questions, it's important to consider what key feature they're asking us to look at. If I take my workspace over here, and I model out what this looks like, right? First of all, they give us this function, f of x equals x squared plus 8x. Just kind of imagine what's happening here. Imagine we have this quadratic. And so I'll have a y-axis here. I have an x-axis here. Right? If I were to take a quadratic and I were to draw it, so let's say it has a y-intercept maybe here, and it goes down, continues, it continues, it continues, hits. Let me make that arc against the axis there, and then come back up. And let's say that it also goes up there and stops, right? I give you these kind of terminal endpoints because if this represents a pool, we understand that the sides of the pool, which would be, we'll call it this portion right here. Maybe we draw a little wall here, right? So that's one end of the pool. The other end of the pool is right here. So creating a quick little visual, nothing super fancy here, but you get the idea, right? These kind of measure the walls of the pool. I don't know why they're erasing automatically, but hopefully you get the idea. All this is kind of also filled in. And so that area in blue kind of represents the actual pool itself. Right? And so they're asking us about the bottom of the pool, which is this point right here. And so this question is just a really fancy way of asking you to find the vertex of this parabola, the bottom, the minimum of the depth of the pool. All right. Now, hopefully you remember that when you're looking for the minimum or the vertex of a graph, you start with negative b over 2 times a, which in this case, if we're looking at our function in its standard form, ax squared plus bx plus c. We don't see an a value, so we know there's a 1. We do see a b value, that is at 8. And because we don't see a c value, we can assume that is at 0. Okay? So negative b over 2a here means that we're plugging in 8 for our b. And for our a, we're plugging in 1. And from there, we simplify. Negative 8 is just that, negative 8. 2 times 1 is 2. And that simplifies to negative 4. Okay? Now go all the way. Once we've found the axis of symmetry, which is this point at the x value of our vertex, which we now see is at negative 4, we got to find our y value for the vertex. Hopefully you notice when I plug in here, but for right now, let's just say we got that. So once I plug that in, f of x is equal to 1, or I don't have to write the 1 because we understand that's identity property. So I'll just say x squared plus 8 times x And we're plugging in a -4 for both of those places. Again, -4 coming from what we found there in our negative b over 2a. Once we have that, we just simplify. -4 squared is positive 16, and a times -4 is negative 32. After we subtract those two, we end up with f of x, or sorry, in this case, what we should see is f of -4. That's going to equal -16. So our input was -4, our output was -16, and so our vertex for this pool is going to be at -4, comma, -16. And so you see here that this isn't the most accurate representation of this graph because our point here is to the right of the vertex, but you get the basic idea, right? Let me go ahead and maybe draw... I won't fix it. You get the idea, right? So then our answer for number 3 must be C. All right. So for this one, all you need to do is do that negative b over 2a. And I'll write that here. Number 4, they ask us about a rectangular frame that has a length that is 7 inches longer than its width. They ask us what is the length of the frame if its area is 18 inches squared. All right. So for number 7 here, we're going to do some more drawing to help us kind of visualize what's happening here. So we have this rectangular frame. Is this going to be super helpful to me here? No, it's not. So let me try this. Oh, that's not helpful at all. All right, so I'll do my best to draw a line. That's terrible, so let me fix that. That'll work. All right. So this is going to represent my frame here, and what they tell me is that its length is 7 inches longer than its width. Usually we think of the shorter part of the rectangle as its width, so I'm going to call this shorter side x. And so if that's true, then the length must be 7 inches longer, x plus 7. Okay? So we've got a length of x plus 7, a width of x, and they tell us that the area, everything in the middle here, is 18 inches squared. Okay? Now they're asking us ultimately, what is the length of this rectangle? And so if that's what they're asking for, what we should do is start by thinking about how we would model the area for this rectangle as an equation. Now we know that area is equal to length times width. Or width times length. Community property tells us that doesn't really matter which way we multiply that. And so maybe I'll write that the other way around just to make it easier for what I'm about to do next. So area is equal to length times width. We know our width for this is x. So maybe I'll color code this. And we'll say our length is what's in blue there. And so what that's going to translate to is x times x plus 7 equals our area, which we know is 18. All right. And we go ahead and erase this. Let me put this here to make it look a little more familiar, right? If we want to start simplifying here, we got to distribute. So x times x times 7. X times x gets us x squared, and x times 7 gets us 7x. We still have that 18 over there on the right. And now we have a pretty familiar looking site, right? Let me go ahead and maybe subtract 18 from both sides. And what it's going to look like now is x squared plus 7x minus 18 is equal to 18 minus 18 is 0. So now we've got a quadratic trinomial, and we've got it in its standard form, which means we can solve this by factoring quadratic formula or computing the square, whichever method we want to. And we can do that fairly easily, probably the most easily, by factoring. So for factoring to work, we're going to identify our A term, our B term, and our C term. A term is the number in front of x squared, that is 1. B is the number in front of x, that is 7. C is the number that is a constant, that is a negative 18. And because our A value is 1, our factoring here is made pretty straightforward. If we want to factor, we're just looking for numbers that multiply to get C. So these numbers need to multiply to get negative 18. And they also have to add to get our B term, which is 7. So when factoring, numbers that multiply to get negative 18 add to get 7. Now, luckily, those numbers are pretty accessible to us. The two numbers that we're looking for are either going to be 9 and negative 2 or negative 9 and 2. If we do 9 times negative 2, that gets us negative 18. If we do 9 plus negative 2, that gets us positive 7, which does match with what we're looking for. If we did it with the other two sets of numbers, we still get 18 or negative 18 by multiplication, but if we add these, we get negative 7, which is not a match. So the two numbers we're going to use are right here. And those are going to be the numbers in our factor pair. X plus 9 and x minus 2 is equal to 0. So we just factored this quadratic trinomial into the multiplication of two binomials. And when we multiply these two binomials, we're ending up with this product of 0. And that's only possible if one of those binomials is equal to 0, and that's called our zero product property. So either x plus 9 equals 0 or x minus 2 equals 0. And then you would just do the work in each case to get x by itself. So those are our two solutions mathematically. But in the context of this real-world problem, only one of them really makes sense. If we go back to where we started, right, this rectangle has a length of x plus 7. And so whichever one of these x values works is going to be the one that ends up in a positive number, right? Because distance can't be measured negatively. So looking at the 2 here, if we did negative 9 plus 7, that would get us a negative 2, which is not a real distance measure, which means even though it's a mathematical solution, it doesn't work as a realistic solution. So we're left with x being 2. And if we check that, x plus 7, based on our solution, we can put it into 2 plus 7. And 2 plus 7 is 9. So that is a real distance measure, and it's the only one of the two mathematical solutions we got. So that must be the correct answer. And if we look over at number 7, sorry, number 4, that is an answer choice. Our answer is 9. So A. Okay? So pay attention to that one. Once you're done solving, you're not done answering the question because they ask you to take that solution you found, the realistic one, and plug it back into the situation to get the length they've asked you for. Number 5. They're asking about the height of a projectile launched from a 20-foot tower that is modeled by the equation y equals negative 16t squared plus 32t plus 20. Part A asks us to select the graph of the equation. That's our answer choices here. Part B asks us what is the maximum height in feet reached by the projectile. So, to tackle the first part, this problem asks us to do something very similar to number 3. Given this equation, we're looking for the maximum height, and that looks like that's one of the discerning characteristics from each of these graphs. It seems like a good place to start would be, let's just go ahead and do that. Let's just figure out what the vertex for this function is going to be. Negative 16 t squared plus 32 plus 20. This is number 5. So negative 16 t squared plus 32t plus 20. Let me triple check that to make sure that is correct. Yes. All right. And that's equal to f of x. Again, if we're looking to find the vertex, that means we're looking at a negative b over 2a. From number 3, we recognize that our b value is the number next to the variable that's not being squared, that is t, and so our b value is 32. Our a value is the number that is next to the t squared, that is negative 16. And be mindful of the sign next to the variable. It's negative 16, so we got to make sure we bring that negative when we plug everything in. Let's simplify. Negative 32 is just that. 2 times negative 16 is also negative 32. And negative 32 over negative 32 is positive 1. So our vertex is at positive 1 on the x-axis, and that helps us eliminate none of our answer choices, because all of them have that x value at the vertex of positive 1. They probably knew we were going to look to see if we could eliminate any answer choices. They did not do us a solid there. So then we're going to go ahead and we're going to plug in that 1 and see what the y value for the vertex is. Maybe we'll have an easier time figuring stuff out from there. So if this is the equation, or the function is given to us, f of x equals 1, then everywhere we see a t, and that shouldn't say f of x, it should say what? H of t is what they named it as? Let me rename it. Let's be as precise as possible here. Everywhere there was a t, we're going to go ahead and we're going to plug in a 1. And from here, as long as we follow the order of operations, we can't mess this up. 1 squared is 1 times negative 16 is negative 16. 32 times 1 is 32. We're still adding that 20. Negative 16 times, or plus 32, is positive 16. Positive 16 plus 20 gives us h of 1 should equal 36. So our vertex should be at the point 1, comma 36. Let's see if that helps us out at all. So if we look at answer choice A, the y value here is above 40. Looks like they're trying to get us to say 48 there. We know that 36 is what we're looking for, so that cannot be it. B gives us this y value, this y-axis floating above 32, and this one seems to be counting by 8, so this is 24 right here, 28, 32, 36, so that one makes sense. Answer choice C here says we've got this y value that seems to be just above 30, but only just above it, not close to 40. We'd expect, if this graph is drawn proportionally, that top, if it was 36, would be closer to the 40. So that doesn't look like a correct answer. And our last one here gives us a maximum value at 20 on the y-axis. So that's no good. That can't be the correct answer either. So then the answer must be B. And when we're asking for the maximum height, we found that at 1, 36. So the maximum height is 36 feet. All right. Jumping to number 7, we're asked to write the product of 3i times 5 minus 3i in the form a plus bi. So they want us to write it as a complex number. 3i times 5 minus 3i. And this was number 7. All right. So this is just distribution, right? We're going to go 3i times 5, 3i times negative 3i. And that's going to give us a product of 3i times 5 is 15i. And 3i times negative 3i is negative 9. That's 3 times negative 3. I times I gets us I squared. Okay? Now we're going to reason a little bit. 15i is going to stay that way. Negative 9 can stay that way. But I squared can be simplified a little bit, right? Because we know that when we're talking about I, the imaginary number, it is equal to the square root of negative 1. So if we were to square I, that means you're taking square root of negative 1 and you're squaring it. And because square roots and squares cancel out, all you're left with is negative 1. So what was I can now turn into negative 1. And if we simplify that further, negative 9 times negative 1 is positive 9. Now, because they want us to write that in that notation for a complex number, a plus bi, we're just going to flip around that 9 and that 15i, and now it's going to say 9 plus 15i. And so that should reflect our answer, which it absolutely does. Our answer is D. Jumping down to number 10, we're asked to solve x squared plus 5x equals negative 8 using the quadratic formula. X squared plus 5x equals negative 8. All right. So for this one, what we're going to have to do is solve with the quadratic formula, which, as you hopefully remember, reads x equals negative b plus or minus the square root of b squared minus 4 times a times c, all being divided by 2 times a. All right. And before we can use the quadratic formula, first we have to write our equation in its standard form, which is asking us to make the equation equal 0. Easiest way to do that is to add 8 on both sides. We end up with x squared plus 5x plus 8 equals 0. And if that's true, then we know our a value, the number next to x squared, is 1. Our b value is 5. And our c value is 8. And we're just going to plug in. So x equals negative b plus or minus the square root b squared minus 4 times a times c, all being divided by 2 times a. B value is 5, so that's going to go here and here. A value is 1, that's going to go here and here. Our C value is 8, that's right here. And so now we're just going to simplify until we cannot anymore. Negative 5 is just that, negative 5, plus or minus the square root of 5 squared is 25. Negative 4 times 1 is negative 4 times 8 is negative 32. And that's all being divided by 2 times 1, which is 2. We can do that subtraction under the radical. So negative 5 plus or minus 25 minus 32 is negative 7. Being divided by 2. And if we wanted to take it one step further, what we could recognize is square root of negative 7 is the same thing as saying square root of negative 7 times the square root of negative 1, which we remember we can just, or not negative 7, but positive 7, which hopefully remember is just the same thing as saying negative 7, square root of 7, and the square root of negative 1 is I. So if we wanted to write it one more way, simply put, we could turn it into root 7 I. And that's all over 2. And that is our answer. Now what you're going to write here based on the space allowed is negative 5 out here. You can put negative 7 in here. And on the bottom, you could put 2. And that is that. Let me double check to make sure that's true. Yeah. Take a look at number 11, which says, what is an equation for the quadratic function through the origin 10.25 and negative 0.25, or negative 10.25? I'll try that one more time. 10, 2.5 and negative 10, 2.5. So it's passing through these 3 points, and it doesn't look like 3 because they kind of sneak in the origin there. So let's picture this. We've got this coordinate grid, right? That's pretty decent. They say it passes through the origin. When you go 10 to the right, you've got a point up here at 2.5. So I'll put that point. But they also say when you go 10 to the left, you've also got a point at 2.5. So what that must mean is the origin is acting as your axis of symmetry here. Because if you go to the right 10 spaces or to the left 10 spaces, you've got a point at the same place on the y-axis, 2.5. And so we can go ahead and write the vertex form, which originally looks like this, for this equation, or for this graph, pretty easily. Because the vertex form says h and k are the coordinate pair x and y for the vertex, and we see the vertex here is 0. Right? So we do that. Y equals a x minus 0 squared plus 0. Simplifying that, y equals a, x minus 0 is just x, and plus 0 just goes away. So ultimately, the only thing we really need to find is our a value. And the thing that's going to help us do that is the fact that we have numbers we can plug in for the x and the y, right? They tell us both of those numbers, and they give us two choices, either 10 2.5 or negative 2.5. So let's use the positives just to keep things easiest. Instead of y, we're going to write 2.5. That's going to equal a, which we still don't know yet, times 10, which is that other value we know, x squared. So by taking those points they've given us, as well as the vertex they've given us, we can plug in everything and then just simplify and solve until we know what our a value is going to be. And so we're at that next step. From here, it's order of operations. 10 squared is 100, so 2.5 equals a times 100. And to solve, we're just going to divide everything by 100. It's going to give us a is equal to, dividing by 100 is the same thing as moving a decimal 2 places to the left. So if it started here in 2.5, 2 places to the left puts it here. And so now we're at 0.025. So a is equal to 0.025. Now, if we wanted to turn that into a decimal, or rather, it's in a decimal form, we want to turn it into a fraction form, because the answer choice asks us to write it as a fraction, we'd write that as, this is 25 thousandths, which, if we wanted to simplify, is the same thing as 1 over 40. And so that's the number we're going to put in next to x. Number 13 says, what value or values of b will cause 8x squared plus bx plus 2 equals 0 to have one real solution? So for this, we just got to think about one specific portion of our quadratic formula. That is called the discriminant. And the discriminant is the part that's under the radical. So b squared minus 4 times a times c. They're asking for when this graph would have one real solution. And that's true if the discriminant, when you plug in b, a, and c, is equal to 0. All right? So all they're asking us to do is pick a value for b that would make the equation equal 0, this specific one over here. So we're going to do that. So 8x squared plus bx plus 2. And we're plugging in for b squared minus 4ac. So real quick, I'm going to try something here. Let me see what happens if I try to solve this algebraically. So, to do that, I'm just going to take all that. Let's move it down here. We're going to set it equal to 0. And I'm going to plug in the a and the c that we were given, which are 8 and 2. So b squared minus 4 times a times c. Our a value is 8, and our c value is 2. Okay, let's simplify over here on the right. B squared is going to be negative 4 times 8, which is negative 32. And negative 32 times 2 is a negative 64. Okay, now from here, all I got to do is add 64 to both sides because we're trying to get b by itself. We're going to end up with b squared is equal to 64. And the last thing we're going to do to get b by itself is to take the square root to cancel out that square. We're going to end up with b is equal to, the square root of 64 has two possible solutions. We could either say that it is negative or positive 8. And so our answers, the two numbers we could plug in to make this equation equal 0, are negative 8 and positive 8. Now, if you wanted to, you could also just settle for plugging in every single one of your answer choices into b squared minus 4ac and seeing which ones are going to make the equation equal 0. But what we just did is far faster, right? So I would recommend definitely using your brain a little bit, plugging in the a and the c from the equation, and then just solving for b once it's set equal to 0 to figure out what your numbers are going to be. Now our last one here, number 14, asks us to determine the number of real solutions to the system y equals x squared plus 1 and y equals 1. So for this one, all they're asking us to do is solve with substitution. And so we're going to do just that. Y equals x squared plus 1, y equals 1. And the key here is to remember that in a system, you're looking for the place where the y's and the x's are the same number. So if you're told that this y and this y are the same, and that this y at the bottom is equal to 1, you know that this y up here is also equal to 1. And so we can substitute 1 in for y up here. So what this is going to look like now is 1 is equal to x squared plus 1. So now all we got to do is we've got to solve for the x. And this one's especially easy because we're given just one kind of x, right? We're only having an x that's squared. So we just subtract 1 from both sides. There's a 0 equals x squared. To solve for x, to get rid of the square, we're just going to take the square root of both sides. That's going to be x equals 0. And so there's only one place where those two lines cross, and that's going to be B, one solution. The one solution is 0. And that's that. So those are all the questions we did not get to cover in class. Do not stress about, or rather, do not overthink these questions. These questions are all mostly review from your Algebra 1. There's nothing here that's really going to stretch you too far. So as long as you keep in mind the fundamentals, as long as you think about your quadratic formula, completing the square, solving by factoring, as long as you remember those, the rest of this test is pretty much application of old concepts. With that being said, I'll see you in the next video, and thank you for tuning in.